Okay, so today I want to go into where I'm at with the Roomba. Ignore all the electrical tape holding everything down. So, I'm actually going to be taking out these wires that I ran to the buttons. I did use that for testing. It worked okay. I was using these MOSFETs to control them. But I decided to just go a different direction and use the serial interface to run this guy. So today, I'm not sure exactly what we're going to get into, but I want to run over what I've done. I'm going to give you a quick explanation of what this guy is here and where we're at. I didn't actually get as far as I wanted to with this for this video, but it all works, and I'm going to show you that now. So here's the Roomba. And here is, I'm connected to it. See if we can get this in here. So right now I'm running this script, and I'll tell you in a minute which one this is, and I'll include it in the link below. We have Nibbler here, absolutely happy, wanting to be in everything. So this script here, it's created by another guy, but it opens the Roomba's interface based on your serial number and what GPIO pin we're using to initiate the startup. So this guy is our GPIO pin number 27. So, so what we're going to do is we're going to let this run. So now through the wireless we're connected, it just turned it on. Now it runs a script. And this Roomba isn't one of the Create 2s. It obviously it's just a regular one, so it doesn't know exactly what firmware it has. And some of the controls are a little bit different because of that. So it's on, and like I said, I'm going to go through this interface in a second. But basically this is just a serial interface and voltage regulator to control the Raspberry Pi, because the Raspberry Pi has no other wires hooked to it. So what I'm going to do is we're going to save the commands. So the Roomba has all different kinds of modes. You can read into that, but for the time being, to get it to do anything, we're going to turn modes to safe. And with this script that exists, more or less, it's hard to do holding the camera. So I just have some commands here that I kept, so that way I could quick reference it, because I need to make a script that lets me control this through the website. One exists, but it's based on old PHP and curl. Doesn't seem to work anymore, and I didn't have the time to really start diving into diagnosing it. So I just want this robot spin right, and I don't have a tripod handy, so as you can see, it's talking. Told to spin rate 50. You can go up quite a bit in speed and quite down. Let's do, I think this is the slowest you can do, 15, and it's pretty slow. It almost sounds like this motor's on its way out, but that's okay too. But yeah, so it's talking, it's working. You can also send it. An oddity with this one is if you come here and do robot dot clean, it'll do the clean command. I just send it again and it'll stop. There is a command in here that I think works on the Create. I think it's robot.stop. That does not work on this Roomba. You just send the clean command again to turn it off. Well, not to turn it off, but to stop it. And so if I go like clean, then I go stop, won't do anything. So you're saying clean again and it stops. So my cat is like, what's going on? But yeah, so I'll give you more information about this script in a minute. I did not write this, that's why I'm gonna let you, I'll tell you where I got it from and how to set it up. But more or less what I want to show here is the serial interface. So I made this little breadboard, and we'll take this off in a minute, but more or less let's go through it. So we got our 2 power lines that come in from the Roomba. They go into this voltage regulator, which I have an open one here. I'll include this below what it is exactly, but if you look, it's just got in on this side. Let's see if we can. So it's got in on this side, so you can put in up to I think 32 volts, and out on this side. This is where you give it the output for the Raspberry Pi needs to be 5 volts, and actually for this chip, which is a logic converter, this needs 5 volts and 3.3 volts. So what this guy does is it converts it down, and yeah, this is the correct one. So what I did on this is you run obviously whatever voltage is coming out of the Roomba into this, and then you have to turn this, I think it's counterclockwise, but you really need to hook up a voltmeter to see what's coming out of it. Just make sure you have a voltmeter handy, it could be a cheap one, whatever. And you just monitor the outputs until you get it down to roughly 5 volts. Doesn't matter if it's a hair above, a hair below. I didn't realize there was a screw on here. So we brought this guy down to 5 volts-ish, and this was the one I used to test everything. These come with a little LED right there, if you could see it next to that. There's a resistor, and then right next to it was an LED. It was so bright. It actually helps you when you adjust the voltage down, so the LED gets a little bit dimmer. But I don't want that running on mine, so I broke it off of this one, and it's actually, you won't be able to see it because it's covered right now, but back there it's broken off of that one. No, actually, it's right over here. I broke it off there. Make sure you don't break the resistor that's there. But I broke it off right there. That'll be easier probably to see. Right, it's that one I broke off. That one, don't touch. But yeah, so I'll include these guys down below. I know there's smaller options for this, but there's what it's called, an LM2596. This was fine. They were cheap. That's why I bought them. They come in a little bag, and I think I got it's like 6 for $10 or something. So basically, voltage comes in from the Roomba, goes through this. I really think you should have the fuse before it comes in here, but I fused after just because when I built this, it was more convenient and I needed the room for this. This is actually overkill. We don't use most of the channels of this. This is an 8-channel logic converter, I believe. Yeah, it's 8. We need 3 channels to logic convert. That's it. So here's a smaller one. I had a bunch of these ones, so I used this one in the final one. But this one's a 4-channel. 1, 2. Yeah, this is a 4-channel logic converter. This one works fine, and I use this, as you can see, for testing everything. But I could have just done the 4-channel on here, but I have a bunch of them, so that's what I went with. You can go with whatever you want. I'll probably include this one below. But yeah, so basically voltage comes in here, high voltage, comes through this, gets converted down to 5 volts. Runs through this fuse. This is a 1 amp fuse. It's just an automotive fuse. Here's one. I just cut it down. I cut off the sides and I connected directly to the 2 prongs that are in there. So also really cheap. So that's there. I soldered this down well on both sides so that way it doesn't move at all. It's really solid. And then you can see this is the ground that comes out. I know my solder job's amazing, but that's okay because I needed to make connections across. So this is ground. The yellow wire is ground out to here. This goes into pin 3 on the Raspberry Pi. The first 2 pins right here, that one and the next one to it, are 5 volts. You can actually solder. There's a couple solder points on the Raspberry Pi to solder them on, but I'm just using that for now. I actually was going to make a header for this so that way you could just push it right down onto the Raspberry Pi, but I don't know if I'm going to do that because I'd probably have to change the orientation a little bit, but this works fine. So that's that. So then this guy underneath, which I can show you in a minute, the 5 volt comes out here, and then it comes over here to, I don't know how well we will see this, the HV pin. That's high voltage. Then next to it is a ground pin, but you don't actually need a ground on both sides. The ground is actually on the low voltage side on this one. And we have the low voltage in, which is hard to see, but this pin right here is your low voltage. So that comes from this first pin on this side of the Raspberry Pi. That's your 3.3 volts, and that comes around and connects to that pin. So there, the low voltage is actually this pin. Next to it is ground. The ground is underneath the board, and it runs right back to this. So that's that. And then here you'll see 3 wires come off. That's high voltage 1, 2, and 3. That's these are the high voltage logic high voltage logic lines getting converted down to the low voltage so that the Raspberry Pi can talk to it, and vice versa. Sorry, I'm losing my voice. So the Raspberry Pi pins, which the transfer and receive pins on serial ports are, if you look down this side, which do I have the diagram? It's going to be upside down in comparison to mine, but so you could see on here, you have your 2 5 volts. That's these first 2 pins right here, 1, 2, and then the ground is the yellow one, remember? So it's going, I'm not using the first one, I'm using that one as my input for 5 volts, that one's my ground. And then over here, we're using the 3.3 volt reference. As you can see, this is the card for the Raspberry Pi Zero. And then we're using pin 8 and 10, which is GPIO pin 14 and 15. For transfer receive, this is their serial line out. And then I'm using GPIO pin number 27, which is physical pin number 13, for the button to turn on the Roomba. Basically, it's a wake-up signal. So you just, what the script does is it sets this to low, and that's what turns on the Roomba. So the thing that took me a little bit to figure out, and I know there's not a lot of pins here, but the transfer receive, I had some issues with garbling the text and everything when I first hooked this all up, but actually rebooting the Roomba fixed all that. I took the battery out, restarted it, got it back on, and then it all started working. I actually tried another one, and it had the garbled text too. I don't know. The only time I ever did this before was with the USB ones, so that was easy. You just plug them in and go. But we made our own serial interface here instead of using the USB one. So we need to reference the transfer and receive lines of this. So we can double check this in a minute, but one of these is transfer, one of these is receive. Actually, we can probably figure that out because you hook them up backwards, I believe, to this. But either way, we'll look at the Roomba thing in a second. But one of these is transfer, this yellow one, or this red one, transfer and receive, and then this is the wake-up pin. The wake-up pin just comes in, goes through one side here, and then goes back to the blue one. So the first one on here, if you were duplicating mine exactly, it doesn't matter which one of these you use as long as you get the right connection from one side to the other. So on this one I used high voltage 1 from this pin on the Roomba, which I'll show you a diagram of that in a minute. And it goes through and goes back to pin number 27 on the Raspberry Pi. Then the other 2 lines, as long as you have them hooked up correctly, I did high voltage 2, high voltage 3 here. Like I say, it does not matter as long as it's not the ground or the power in, the HV line or the LV line. The rest of these are the through logic converter pins. So what I did was I just ran the other 2 through, and then you can see a red and a yellow here, and they just go around, and you'll see the red and the yellow here. So that's all it is. And then the script does the rest of the work for you. So you're just making a serial connection to the Roomba and then sending it commands. That's all. So let's hold on 1 second and I'll show you the diagram of the Roomba too. So this is the Roomba's output, and this is actually, well, here, this is the Roomba's output. So we're referencing pin number 4 and 3, and the wake up pin, baud rate change pin, number 5. So 3 is receive, transfer out serial output from the Roomba, and input. So input is port 3 and output is 4. So that's what we're referencing right here. And just so you know, as you can tell, obviously my little adapter plug that was supposed to go in here has not come in yet. We'll see what I'm going to do in the future. This stuff may be hidden inside of this somewhere, but I don't think there's enough room for this unless I went with a smaller fuse. So that's something. I was actually thinking about just making a case that I could put right over the top to do this. But either way, it's functional. So it's not pretty, but it's functional. And ignore the tape. I just put this on here so none of these wires would get ripped out. I need to open it up and remove the wires that go to the clean and the dock button, because they're totally unnecessary at this point. So, but for my testing, they worked. So anyway, we're going to go into how I built this board here, and then probably in the next one we'll go into the piece of software that I showed you that actually controls this. So what I'm going to do is I'm going to take this little board off so we can see the underside of it too, and I'm going to disconnect the power for right now. And yeah, I'll just go over how I made this board real quick. Okay, so I just want to show you the underside of this first. I'm not going to disconnect everything right now. I just unscrewed this. I have one screw that holds it in for the time being until I make some holes to hold it down a different way. But I just used that guy right there to hold it down. So if you look at this, there's the top, and here's the bottom. So all I'm doing, all these wires that you see here, this is a ground that's just being brought over to this other chip. And then this is a power line that's just running over to this chip as well. So that's your 5-volt reference and your ground reference. And then you can see some other things here. These are mostly just to hold down this fuse block and everything. Like I say, it's not beautiful, those connections, but it's to make this sturdy. The actual connection runs out the side and goes through. There's a pin right there that comes through. I just wanted to make it so it was sturdy, so I didn't break it by just touching it. So yeah, and you'll see a couple things here, like these 3 pins, they're just off of this board. I made it so that way it would be solidly attached, because if you look at these boards, they have 3 pins here. I just soldered them through to hold it tight, and then I also soldered through this connection point on this side to hold it down. See, that guy right there holds it down there. And then the ground, you know, off of there actually holds it down pretty good, like it's solid. So yeah, that's that. That's basically the bottom side. These didn't come out pretty because I was having trouble getting them to go across, but it all is functional, as you saw. So yeah, the next thing here is I'm just going to show you the individual components, just so you can see how I did it, so you can make it if you have the interest. Just remember, if you blow up your Roomba and all that, that's on you. I'm here just showing you what I'm doing because this was a fun project. Oh, another thing that I didn't get to talk about before we go into that, this camera and the mount. So I found this mount on, I think, Thingiverse or something, but if you look closely, it works fine, except for the fact that the camera that I have didn't fit in here. So all I did was I'd use some hot glue to hold the camera module in there, and I mean, it works fine. But so yeah, so yeah, so like I said, this did not work with my camera, but I just made it work. So it's actually a really nice design. I just threw in a screw to hold the thing. It's just the actual Raspberry Pi module I have must be different than the person that made this one. It's just quite a bit smaller. If you can see through there, you can see how it's smaller than the actual thing. So I just modified a little. I'm not going to include this because it obviously won't work for most camera modules, but I made it work because I didn't feel like printing a new one, and a little bit of hot glue solved my issue. So yeah, that's about that. So I still need to come up with a solution to attach this. Probably just double-sided tape, because I don't really want this to be permanent, because I'm sure eventually, after I'm done messing with this for a little while, I'll just be removing this and putting this Roomba back to doing its normal duty. But it's a fun project either way. But you can also use this for, if you wanted a surveillance robot at home, you can just use it, so when it's sitting on the dock, you can wake it up and tell it to go do things. So alright, so let's look at the board and everything. Let me get it all out, and I'll show you. Okay, so really this is all that's involved in making that little board I got up here, plus a handful of wires, etc. But this is your voltage regulator, like I showed you before. And like I said, all I did was I put it on the side. You could do this however you want. You could keep this separate. You could just reference the wires back to your board. You could even just do what I did in testing, is I made that and I had these just hooked up. I just wanted a way to put fused power into my design somehow. And like I say, I am no expert in any of this. I am just putting it together so I can use the Roomba how I feel like using it. But yeah, this is that chip. The logic converter, as you can see, you just really need to connect to the, let's see if I can get this a little closer. You really need to just put 5 volts to the HV line. You need to ground either side, one of the ground lines. You need to put 3.3 volts to the LV line. And then you just go serial in and out, and the wake up pin, the BRC pin, I believe is what it's called on there. So that's all it is. You're just putting, this is so that, because the Roomba works with 5 Raspberry Pi, uses 3.3 volt logic. You're just running the logic from the high volt side to the low volt side. So the Roomba goes on the HV side. Let me put this here. The Roomba goes on the HV side, and which HV stands for high voltage, and the outputs go on to the Raspberry Pi to the low voltage side. So high voltage, 5 volts, low voltage, 3.3 volts. And you're just making it so that the signals coming out from here can be read by the Raspberry Pi. So Roomba, high voltage, Raspberry Pi, low voltage. That's all it is. And this literally just bumps it down so that they can understand each other back and forth, because it is a back and forth communication. So that's all this really is. One thing I read about these on Amazon was that the pin spacing is a little bit off. I guess it's compared to normal ones. I didn't actually have any trouble. Seems to fit okay. Let's see if I can make this work for you. Yeah, I mean, I just pushed it in. It feels a little like friction fit tight, but I mean, it's fine. It might just be that this board is not, or the holes are a little bit bigger on it or something, but it works. Like, none of this is soldered. I'm just using it as an example, but I don't know. Seems to work. It does exactly what I want it to do. So that's that. So, and like I said, the fuse, like, I think if I were to do it again, I would somehow put the fuse behind this initial input here, because I would think that's where you want it to be. But either way, this is an automotive fuse. You can do 50 different things to fuse this out. I just had a bunch of these, so I was like, whatever, I'll use this. And these little PCB boards, they come a ton of them for really cheap now. So anyway, that's about it, I think, for this video. More or less, all we wanted to do was convert the logic from the Roomba so that it could talk to the Raspberry Pi. So that's all we did here. In the next video, I think I'm going to try, it might not be the next video, depending on my timing. I might have something else in between. I want to talk about the script, and like I said, I'll put the script in the description below, how I interfaced everything, and yeah. So more or less what we're going to do in the next one is probably talk about how to install the software and go through the general setup for this. I probably won't go into every detail, because basically installing Raspbian on these, you can find a million videos of that. You install Raspbian, you're turning on the serial interface, you're installing a handful of things off of a website, and then basically you can control and run this Roomba. And there's a few other options. You could also use the USB interface, which I actually have one here. This USB interface you could use, so that way you don't have to do any of this wiring. You just put a USB port right to the Roomba, to the Raspberry Pi, and then you can just plug this directly in here. And as you can see, this is the port that I need, but I'm not going to kill this cable for this project, because like I say, you could use this cable specifically to do all this. So if it's easier, go for the cable, but I was more interested in trying this out and making it work. And like I said, you can make this whole thing much smaller if you use one of the small ones. I'll try to include both of these in the description. These ones, for some reason, even though they're smaller, they were a little more expensive than these ones, but they are legitimately the same thing. If you look, high voltage, low voltage, you're just going to use less space and less pins, obviously, with the small one. So anyway, that's it. I'll see you in the next one.